So again, my presentation is about incorporating machine learning and deep learning in online dance education. So why did I choose dance as my problem? So there are lots of people who dance. In fact, almost 25 million Americans dance. And a lot of people dance at studios and attend in-person studios, but especially due to the pandemic, since the studios closed, many people had to learn dance online through online services such as Zoom. And even after the pandemic and as studios have started to open up, many people still continue to learn to dance online. And because it has several benefits, one is more flexible for them to fit online dance in their schedules as they don't have to commute to their dance studio. It costs less, and people who live in remote areas who live very far from dance studios can still learn to dance through online dance education. However, there is a big issue with learning to dance online, and that is it's easier to incorrectly learn a dance move without a teacher physically present to correct you. And because a teacher can only assess you through a tiny screen. And because you can't learn a basic dance move, there will be more difficulty progressing to more advanced levels because the basic move is like the foundation. If you don't know how to do a basic move, then you can't really do a harder move. And incorrectly doing a dance move can result in injury that can prevent you from dancing for a period of time. So my proposal is to try to help people understand whether or not they did a move correctly or incorrectly by using an AI algorithm to detect correct dance moves from incorrect dance moves. So the students can use this feedback to improve, and the teachers can also use this feedback to improve and help their students more in instructing them on how to do the move more correctly. So there have been prior approaches in the field of dance in terms of AI. Many people have tried to track dance movement by using physical devices and hardware as seen in the right image. This dancer has a lot of sensors all over her body and even a camera to track them. Other studies have used this information of like the movement of a dancer to track dance-related injuries over time. That means to prevent the dance-related injuries. And other studies have detected the movement among multiple dancers at the same time, as seen in the left image. So our approach is different from this because we want to avoid using sensors because this can be hard to dance with, and having every online dancer purchase sensors can be very costly. And we only want to track a single dancer because typically in online dance, there's only one dancer at a time. And we also want to detect whether or not the basic move is correct or incorrect. So these are my requirements for the dance algorithm. So we want to analyze a full audio video clip of a dancer from head to toe. And that is because you have to, when doing a certain dance move and determining whether or not the move is correct or incorrect, you need to consider all of the body parts. You have to take all those into consideration, not just the movement of the legs, but also the movement of the arms and head. And I chose to focus on a relatively basic move in ballet, as seen in the GIF below, which is a grand plie, which involves a bending of the legs until the thighs are horizontal to the floor and the back is straight, because this move is a foundation to many other moves and more complicated moves in ballet, including leaps, for example. So we want to use the full body video clip and do that to determine whether or not the grand plie is correct or incorrect. And we want the algorithm to detect certain qualities of a grand plie, one being the smoothness and continuity, because this is an important component of a correct or incorrect grand plie. We don't want the dancer to have any abrupt movements or a lot of dancers, when they make a mistake, they stay at the bottom over here for too long. And we also want the algorithm to detect other essential factors where dancers can possibly like do incorrectly, such as the heel placement, whether or not they are leaning forward or backward, and other stuff. So to collect data and do our data processing, we first collected video clips of grand plies from dancers by recording some individuals who consented to its use, and we also found videos online. And then we use MediaPipe, which is a machine learning solution for tracking the movement of various body parts, and to convert our videos into landmarks. So as seen in the left image, it captures for each frame of the video, it captures where certain body parts are, such as like the hands, and the coordinate locations of those landmarks as data. And we want to analyze these frames and feed that into our different machine learning algorithms. And I decided to use MediaPipe pose because I've seen how it has been used in other movement and other research, and I wanted to try it with dance movement in particular. So this is a breakdown of the data set. So to clarify again, we have two categories, a correct grand plie and an incorrect grand plie. And I was able to collect a total of 76 videos, 42 videos of correct grand plies and 34 videos of incorrect grand plies. And for each video and for each frame of the video, these are the 33 pose landmarks that MediaPipe maps out, ranging from like left shoulder to right ankle. And for each pose landmark, MediaPipe tracks the X and Y coordinates, like the position, the depth, and the visibility. So therefore, there are a total of 132 data points per video. So we did 3 different methods. For my first method, what I did was I tried to only look at the middle frame of the video. So these rectangles represent all the frames in the video. And then the yellow is the middle frame. I wanted to look at the information, like the pose landmarks in that video. And that counts as an input for the machine learning algorithm. So this represents 1 data point per video. For my second method, instead of just doing 1 frame, the middle frame, I located 2 frames, which are in yellow, near the middle of each video. And I took the difference in landmark positions of these 2 frames. And the reason why I did this is because I wanted to track the smoothness and continuity, because if the difference in the positions of the poses, for example, are very small, that could signify that, and this is near the middle when the dancer is towards the bottom, that could signify that the dancer is just sitting in the bottom for a long time rather than smoothly going up. And if the difference is too large, that could mean that they are moving too quickly back up or down. So we would want the difference to be not too large and not too small. And we did this for every video. We took the difference between 2 frames, so that represents 1 data point per video. So for our third method, we took into consideration that the data set size was relatively small. So I wanted to augment the size of the data. So in addition to the previous method, I took 2 other interval shifts, such as like 20 frames before the middle frame of the video and 15 frames after. and I found the difference between those, between the pose landmark coordinates of those. And so for each video, there would be 3 data points. So to compare again, these are the 3 methods that were implemented. The first one was just to track the middle of the video, and that would theoretically be when the dancer is, their knees are fully bended down. And because there's a lot of room for error when the dancer is at that stage. The second method was taking the frame difference at 1 interval shift of the video. The third method was taking the frame difference at several interval shifts. So now onto the experimental methodology. So I used 3 basic machine learning algorithms: random forest classifier, KNN, and MLP. And I decided to use more simple algorithms because it could be easier to deploy these algorithms into an app rather than some more complicated algorithm. And I wanted to see if my method would work on basic algorithms before I went to more complicated ones. So these are the hyperparameters that I ran it through. And I iterated through the estimators and max depth for random forest classifier. And I changed these hyperparameters around to have a total of 49 experiments. I did the same thing with KNN, and I iterated through the number of neighbors with a total of 10 experiments. And with MLP, I iterated through the learning rate and max iteration for a total of 40 experiments. So these were the results of each method. So for the first method, after running it through all these 3 algorithms, these are the accuracies that the accuracy ranges that the different experiments reached. So I found that MLP achieved the highest accuracy, 78.26%, but KNN also did almost as well, 75%. And MLP appeared to be the most sensitive to the hyperparameters, whereas random forest classifier and KNN didn't appear to be as sensitive. So for my second method, I found that the frame difference at 1 interval, the accuracy results were lower than the previous approach. Random forest classifier did have the highest accuracy, but KNN, for example, dropped to an accuracy of 50%. And then for the third method, I got considerably higher results with an accuracy of over 90% eventually for all algorithms. And this could have been because we added more data, but it also could be a sign of overfitting as this reached an accuracy of 100%. So overall, we found that all the algorithms had very similar accuracies, but that random forest classifier ended up having the highest accuracy for the last approach, over 90%. And we found that the last approach was more effective and had the highest accuracy. And this could have been because the data set was a lot bigger and it tripled to 228 samples as opposed to 76 samples. But it also could be a sign of overfitting because the accuracies were so high. So I do agree that the data set size is a limitation because there are only 76 data clips. And I would really like to work on trying to increase the data set size and ensure diversity within the data set because there are lots of diverse dancers, different body types, and also different heights. And I would like to make sure that the data set, therefore, is very diverse. And there was a slight imbalance between the correct number of correct grand plies and incorrect grand plies. So I tested it with SMOTE, which is known as synthetic minority oversampling technique, which tries to create a balanced data set by replicating some of the, in this example, would be the incorrect grand plies to make it fit with the number of correct grand plies. And I figured that doing this produced pretty similar results, and it also had the highest accuracy at the last approach with accuracies of over 90%. So in conclusion, in future work, I created an algorithm to detect is a grand plie correct or incorrect in the video clip, and found that the last approach, taking the frame difference at several interval shifts, method 3C, was the most successful with a 90% accuracy, and the other two methods that were examined resulted in lower accuracy. So in the future, I would like to focus on collecting more data and also experimenting with different dance moves, because different dance moves have different criteria on what makes them correct or incorrect. And also different dance styles. For example, if I were to predict whether or not a turn was correct or incorrect, I might look at something else other than the smoothness, although that would be a factor, such as like the foot placement and whether or not there was any hopping. And it would be nice to deploy this in an app so other people can use, but before that, I would like to focus on trying to add more data and seeing if the results are still high. Yeah. And I think that is it. So thank you for listening.